So in this video, we are concentrating on proving trigonometric identities. Remember that to prove a trigonometric identity, we cannot treat it as if it was already an equation. We have to focus on one side or focus on the other side and hopefully show that one side actually is just another way of writing the other. I'm going to focus on the left-hand side because the left-hand side is clearly the more complicated side. And we have many options. One reasonable idea would be to change these trig functions back into the sines and cosines that are used in their definitions. That's often a good idea. But what I'm going to do instead is I'm going to get a common denominator between this term and this term. It's almost always a good idea to look for common denominators and write out two or more terms as one term with a common denominator. So we have to give this the same denominator, and I'll do that right now. So this is going to become the cotangent squared theta over the cosecant of theta plus 1, and here we're going to give it the common denominator. So we take this denominator and we multiply this term by here it's the cosecant, so it's the cosecant of theta plus 1, which is what that is, divided by the cosecant of theta plus 1. Of course, 1 times this is exactly what we see here. So this is going to become the cotangent squared theta plus cosecant of theta plus 1. And this is all over the common denominator. The common denominator is cosecant of theta plus 1. Now, why would we have done that, and what benefit was this? Well, with a little experience, you start to notice some common patterns. You see this cotangent squared theta and this 1? As soon as I see that, that reminds me of one of the Pythagorean identities. I'll try to remind you of the one I'm thinking of right now. See, every one of you should have this memorized. We all have that the cosine squared theta plus the sine squared theta is equal to 1. That's right. But this was not the only Pythagorean identity. You also need to have memorized the Pythagorean identity that we can get if we divide each of these terms by the sine squared theta. Cosine squared theta divided by sine squared theta, that will become cotangent squared theta, plus sine squared theta divided by sine squared theta, that's a 1. And 1 divided by sine squared theta is cosecant squared theta. This is the Pythagorean identity they're very helpful in simplifying this numerator. See this cotangent squared theta and this plus 1? Well, right there is a cotangent squared theta plus a 1, which means that we can replace this cotangent squared theta and this plus 1 with a cosecant squared theta. So we have here, I'm going to replace these right here. It will become a cosecant squared theta, since that's what it is, plus a cosecant of theta, and this whole thing is over cosecant of theta plus 1. What can we do next? Well, take a close look at what we have on top. Do you see a greatest common factor? Is there anything that is common to this term and to this term? Well, here we have cosecant squared theta, and here is a cosecant of theta. So I'm going to factor out a cosecant of theta from the top. So watch what happens if I factor out. So cosecant of theta from the top here, pulling that out. Well, cosecant of theta times a cosecant of theta plus, and what should I put here so that cosecant of theta times this gives me this? That's going to be a 1. You can check for yourself that cosecant of theta times cosecant of theta is cosecant squared theta. Cosecant of theta times 1 is a cosecant of theta. So that is what the top becomes. What we have on the bottom is right here. So this is a cosecant of theta plus 1. And then notice that there I have a cosecant of theta plus 1, and here I have a cosecant of theta plus 1, which means that these factors cancel out. And what we have left is just this cosecant of theta. And so the left-hand side has been transformed into cosecant of theta. Let's take a look at what we were trying to prove. We were trying to prove that the left-hand side is the same thing as a cosecant of theta. And so, in fact, we have done that. The cosecant of theta is equal to the cosecant of theta. And so this has been a successful proof.